In this video, we're going to make a simple general amplifier using two op-amps. This amplifier can be used to take microphone input and put it into an 8-ohm speaker, or it can be used to sniff around other electronic parts and boards to determine where frequencies might be coming from if you have a noisy circuit. Let's start with a quick circuit analysis. You see here that I'm using two op-amps. One is the LM741 and the other is the LM386. The LM386 is actually an audio amplifier, a specially designed op-amp. At the beginning of the circuit, for the input, we have C1. This is a decoupling capacitor. This keeps DC and some of the lower end frequencies, lower than probably 40-50 hertz, out of the circuit. R1 is a potentiometer used to control the gain of U1. From the output of U1, we have R2, another potentiometer that controls how much of the signal output makes it to the audio amplifier. So in essence, it can be a volume control. The audio amplifier has an internal resistor of 1.35 k ohms between pins 1 and 8 that give it a gain of 20. We bypass this with C2 and make the gain 200. We can actually put a resistor in series with this capacitor. If we put a potentiometer in of 1.35 k ohms, we could control the gain variably. But for this project, I'll keep it to the 200 gain. The output has another decoupling capacitor in order to keep any DC from flowing into the 8-ohm speaker. As with many of my circuits, I like to start with breadboarding the entire circuit. So here I have the entire circuit, both op-amps and all the capacitors and potentiometers needed to connect and test the circuit itself. Once I have the circuit together, I can start testing things and adjusting the potentiometers. As you can tell, there is some noise in the circuit. Which this noise is to be expected given all the different lengths of leads that I'm using for the potentiometers and different speaker lengths, plus it's not shielded. I can actually get more noise by attaching it to my tweezers. By connecting it to the tweezers and then actually pressing it up against the soldering iron, I can actually get the 60 cycle hum from the power mains that are going into the soldering iron. A better test is to connect a small microphone to it and try to produce some sound using that. Next, I can place that same microphone next to the audio output of, say, a small MP3 player and turn the MP3 player on really low. Sadly, I don't own the rights to that song, so I can't play it for very long on this video. But you can see here where I'm very satisfied with this circuit, that it is amplifying, it is taking a good input, so now it's time to package it up. I cut a piece of perf board to fit the box. It'll actually cut down even smaller because the circuit isn't all that large. I then start drilling different holes to mount different connectors into my box. My two potentiometers that I used had pretty long shafts, so I use a hacksaw or a bandsaw to cut them shorter, and I drill the true holes needed for those in the front of the enclosure. I can mount those to the lid of the enclosure using their screws, and then I mount small knobs. These will allow me to adjust both gains for both potentiometer settings in the circuit. Next, I connect two small audio jacks. The top one here will be for the probe to actually take the frequency data, and the bottom one will be for a headphone or the 8-ohm speaker. Then I begin to solder it all together. Here I want to do a nice, neat job. In the end, you should have a tight, compact package with very short leads and a good grounding scheme in order to reduce the noise from the circuit as much as possible. Here you can see the top of the circuit board with all the wires leading into it, the capacitors hooked together, and the op-amps in place, making a very nice, neat package. When I lay it inside the box, you can see the layout that was planned, where the board will lie, and then right next to it, on the right side of the board from your point of view, you will see where the 9-volt battery will be placed. Take note of the large black wire that goes from the small audio jack on the right over to the circuit board. This is for the incoming signal, and that's a shielded cable, a very small one, and that helps with noise immunity, so I don't get too much noise into the circuit from that connection. We'll actually be using more of that to make the probe. To begin making the probe, I take the shielded cable and attach it to the audio jack. The shielded part will connect to the long ground tab, while the center conductor connects to this center pin conductor and solders together. Then, to wrap it up, I can screw the outer shield or the outer casing onto the connector itself. We have a nice finished connector. On the other end, I just pull back the sheathing or the shielding and solder it, where I can now clamp an alligator clip. This would go to the ground of the circuit that I'm testing, and then put a connector pin on the center conductor, which makes my probe tip. Now if we go to test the circuit, it's much quieter, and we only hear that which we want to hear, which is the frequency that we're sampling. For my immediate purposes, I'll be using this as a troubleshooting device. For instance, in repairing this old Chevy truck radio, I can sniff around the circuit and see where odd frequencies may be oscillating that I want to eliminate, or if I inject a test frequency into the circuit, I can see where it actually ends up or doesn't end up. One thing of importance here is this is not to probe anything over about a 35 volt DC circuit. Don't try to hit any 110 volts or any mains voltages with it. You let all the magic smoke out. Well, I hope this circuit gives you some ideas on things that you can use it for, whether it's a troubleshooting device by doing some signal tracing, as I'm using it, or a sound detection. You can hook a little electret microphone up to it and put that microphone at the focal point of a parabolic reflector that's plastic or metal, and you can do some long-range sound detection, much like you'll see at the sidelines of some football games. Or you can do some induction receiver. You can put a telephone pickup coil into the amplifier input, and you can actually sense the magnetic fields around some larger objects such as power lines or the motors. This gives you a lot of different opportunities in playing with a circuit, and I hope you take some chance to play with it and learn a little bit more about it. Happy building.